Hey, thanks for coming, everybody. I'm always impressed when there's a room of people the morning after the party, especially when whatever that fizzy vodka stuff is that you guys had, that was awesome. Awesome. All right, so I'm here to talk about attack-driven defense today, which is kind of rethinking how we do defense. Actually, let me go back. I've tweeted a link to the slides if you have like Wi-Fi or anything and you want to follow me on Twitter, and then you can grab the slides and race ahead and then be like, this talk's going to be boring, and get up and leave. So I run the 4 different security teams at Etsy. This is my first real stint in defense. My background has always been much more on the offensive sort of side, offensive pen testing, offensive research, stuff like that. I was formerly at a consultancy called ISAC Partners, and that's me. I want to give a shout out to these guys. There's no way this talk is possible without the people that are on that list. And then also a little shout out to our friends over at Facebook and Google and GitHub and Square and Twitter and all that. I'd highly recommend collaborating with your peers across both in your individual industry and across industries as well as you're doing defense, right? We're all seeing similar sort of things. We're all, in a lot of cases, reinventing the wheel in some cases even like exactly the same way. And the more collaboration you do, really the better. We've just seen it really pay off quite well. So shout outs to those guys because they're doing awesome work. What is Etsy? Has anyone even heard of Etsy? Cool. All right. Did you just hear of Etsy right now, or have you heard of it? Okay. So Etsy's it's an e-commerce marketplace. I'm sure our marketing people will be mad at me, and I'll butcher this somehow, but think kind of like eBay, but with a narrower focus on more around community, and it's more around like a handmade marketplace and things like that. So lots more kind of handmade and vintage goods and kind of real people making your goods. So then that immediately followed, depending on how many beers people have had, that typically gets immediately followed by like, okay, so why do they even have a security team? And the answer to that is just like the rest of us, APT, except in our case that would be tapestries and not advanced persistent threats. Thank you for the 2 laughs right there. I didn't think I'd even get those. I really thought that was a American-only joke. Awesome. All right. Don't worry, the comedy only gets better or worse. So this talk is about rethinking how we do defense. And historically, we've done defense very uncontextualized. And what this is really about is around how do we do defense around real attack patterns, around ways people are actually compromising systems today. So I said uncontextualized. What do I even mean by that? I'd say if I had to pick kind of 3 things where we've approached defense in the past and where I think we've done it wrong in the past is we've focused on this concept of a perimeter. The perimeter never even existed in the first place, right? It's totally in fashion to say now like, oh, the perimeter has changed and you know we're rethinking defense around like the perimeter is in a different area now and everything like that. The perimeter has never even existed in the first place. We've focused on deploying just off-the-shelf commodity security products. These don't actually address the way people actually compromise systems today. And finally, when we're trying to get some feedback on that and we're trying to figure out where we're weak and where we should adjust, we've treated compliance and we've treated vulnerability enumeration as true pen testing. I've got a whole section on this at the end, but just kind of up front, when we say pen testing has become the most overloaded term imaginable. And pen testing used to mean one thing and now means a whole variety of things. And we think that kind of everything in there gives us a lot of value. And it can give us value, but it gives us values in very specific areas. So I'm going to go into that at the end. Like I said, none of these really address how people actually compromise systems. Like, I'm actually curious, how many people in here are more on the offensive side, whether that's for fun or just professionally offensive people? Awesome. Have you ever been like, oh no, a defender's focusing on the perimeter and deploying security products, guess I'm not getting in, or they've done PCI compliance, guess I better go home, right? There's a reason that these things all cause just complete laughter in the offensive community is that they don't really focus on how we actually attack systems. So that's great. You can stand up here all day and say like, hey, we're doing things wrong, we're doing things bad, but that doesn't actually make things better, right? So where should we be focusing? And that's kind of the subject of this talk. So fundamentally, we really have three things to think about as defenders. We need to figure out how we can raise costs to attackers. We need to figure out how we can increase the chances that we're going to detect compromise and hopefully detect it sooner and sooner in your environment. And then we need to figure out how we can better iterate our defenses. How can we learn from real data and adjust our defenses accordingly, because our defenses are never going to be static. You're always going to be adjusting. You'll notice the one thing that you don't see on here is stop compromise, right? That's a ludicrous notion to say that you're going to stop compromise. Every organization in this room, every organization on the planet can be compromised, and typically pretty quickly. So really what you're focusing on is how do I make it more expensive to compromise my organization, and how am I going to make it more likely that I'm actually going to detect when somebody compromises me? So these are kind of the three sections of the talk as well, and I'm going to do them a little bit out of order. I'm going to talk about detecting compromise first, and then go into some practical examples of how do you make it more expensive and how do you iterate your defenses. So let's jump into detection. Don't worry, there are several kitten slides that are definitely going to happen here. This is really the number one takeaway of this entire section, and really one of the core takeaways of this talk, is just build your defenses from an offensive mindset. Historically, we've approached defense one way, and attackers have approached offense another way. And when you have completely divergent sets like that, then attackers are going to win. So how do we rethink defense along offensive lines? I'm going to kind of condense down the attack chain into these couple things here, these three things here, and then run through some specific examples from those. So we're going to talk about, like, okay, moving from the attack chain side, I initially compromise, I establish some method of persistence and command and control, and I start moving around my network, and then you start doing exfiltration and ongoing actions on objectives. Exfil I actually deliberately left off of here because detecting exfiltration is really, really hard. And at that point, you've pretty much lost the game already. So really you want to focus more on these three, I feel like. Okay, initial compromise. Instrument your endpoints. This is the biggest takeaway I can give you here, is really be focusing on how compromise actually happens. So I'll steal one of my bullet points from way later in the slide, but I'm going to make this number up, but let's say 98% of compromise happens in very specific ways, right? It happens, like the way that we're all getting owned is somebody pops an endpoint, right? Whether that's via a watering hole attack or a drive-by, or more often you just email an attachment, somebody clicks on it, right? You're going to compromise an endpoint, or you're going to compromise some server system with a SQL injection or a remote code exec in WordPress or something like that. But the initial entry points in the network are almost always the same in almost all modern compromise that we see. So this section is really focused on your endpoints. Instrument them. Instrument them as much as you possibly can. And what you're looking for is combinations of system behaviors and commands that are executed and how those systems actually behave. Some specifics of things you want to do: log every command that executes on your servers. This is something that becomes incredibly valuable in both detection and IR later on, and things like that. And what you want to do is you want to start to analyze this data, and you want to start to build anomaly alerting from that data. And so that's a phrase I'm going to be saying a million times throughout this talk, is anomaly alerting. But you need to first, the kind of steps of building a sort of program like this are you need to collect the data, you need to analyze the data, and then you need to gain insight on that and be able to build effective anomaly alerts. Knowing what your baselines are, knowing how your systems actually behave, because attackers in your environment behave wildly differently than pretty much everyone else in your environment. Cool, so I keep saying anomalies. Let's get into specifics. So on the command execution side, something that we've seen be really effective is from a high level, you can generally bucket your organization into technical and non-technical. And that's great because you want to start throwing, you want to get some very high level buckets, and then you want to start to analyze for anomalies based off of those. So in this case, technical versus non-technical, that's great. Now you analyze those sets of data and you say, all right, what's anomalous for a non-technical user? What's anomalous for a technical user? And what's just always anomalous no matter what bucket they're in, no matter what system it is? So on the non-technical bucket, it's very easy, right? If this is a system that should not have a really technical user using it, then anything which shows technical capability is anomalous just by definition, right? If your customer support agent starts opening up a terminal and doing ifconfig and netstat, that's probably not their day-to-day role, right? And that's pretty anomalous right there. Now, notice I keep saying anomalous and not malicious, right? None of this stuff is 100%, okay, that's an attack, something like that, but it is anomalous. And your goal is to get those anomalies to be so rare that they're worth looking at no matter what they are. In the non-technical bucket here, any commands that show technical capabilities, what we've seen this be in practice is that's either an attacker or it's your IT team going over and working on that system for some reason. Technical bucket gets a lot harder. Technical bucket, when you're trying to instrument systems that are used by engineers and used by highly technical folks, they're going to do a lot of things that can seem like attack behavior because that's just part of their day-to-day, right? In the same way where I said, you know, if a customer support rep is opening terminal and doing ifconfig and netstat, that's anomalous for a customer support rep. That's your first 5 minutes as an engineer every day. So what you look for out of that are less individual signals, because those individual signals on the non-technical side are very strong signals. On the technical bucket, you treat those as very weak signals. And what you look for is aggregate spikes, bursts of activity, and kind of unique bursts. Like maybe your engineers do, you know, all of these different commands, but they maybe do them as kind of one-off things. Like I'm working on this, so I do one command over here and one command over here and one over here, but I almost never do that full spectrum, and I almost never do it in 5 minutes. And so you're looking for bursts, right? Because going back and thinking about this from the offensive side, when you land on a system, what do? You start to do recon, you need to analyze like, hey, what did I even just land on, right? I just emailed somebody an attachment. I don't know what system they opened that from. I mean, depending on the recon that you did ahead of time, you're like, okay, well, this person's probably running Windows and they're probably at this area of the network because they published some conference slide somewhere and talked about their network or something like that. But even with that kind of insight, you still need to figure out where you actually are in the network, what you've landed on, all of that. Those come as bursts of activities that are actually very different than the way normal users actually use their legitimate systems. And then there's always anomalous, right? What's just anomalous across all buckets, all systems, everything like that. We jokingly threw in like you name A, right? Think, for those of us from the offensive side, think about what are the things that you always do when you land on systems. And now think about, do you do those when you're maintaining your own home systems? And the chances are that there are a lot of signals that you do when you just pop the box and you land on it that you don't do when it's your own workstation. So thinking and analyzing that data and saying, okay, what does it look like when attackers land on my systems that just never show up otherwise? Okay, persistence. So I'm going to talk about two things in persistence. I'm going to talk about host-level persistence, and I'm going to talk about organizational-level persistence. So host-level persistence, you're looking for common patterns, right? You're looking for patterns of, from the highest level, you know, programs that execute on boot, kernel modules that get loaded, things like that, right? That list can go on for a while, but from a very high level, you're looking for things like that. And one of the most important things to understand around persistence is that you're looking for the off-the-shelf sort of stuff. You have to understand that this is one of those cases where from the defensive side, it's really, really hard to win from the defensive side. Sophisticated methods of persistence are really good, and they're almost certainly never going to be detected as the point where you're actually detecting it in the attack chain. I mean, think about the orders of magnitude difference in detecting somebody added a startup item that runs on boot versus somebody actually rootkitted your firmware, right? These things can get much more advanced, and you're almost always going to lose as a defender here. So what you're going for goes back to my first goal, which is that you look to be able to detect off-the-shelf basic things. You want to be able to force your attackers to have to customize because that increases their cost. If to persist in your organization, they have to change their tooling and do custom development or custom changing of their persistence mechanisms, that just increased their cost. They can reuse their tooling everywhere else, but in that case, they have to customize for you. Before I get into some of the stuff around detecting persistence, I want to give a shout out to some specific guys at Facebook, Mindframe, Chris, a couple of several of the Facebook security team guys did a lot of really good work in this area. And if you guys have never read this presentation, I'd highly recommend it. Mindframe did a really awesome talk that touched on some of this stuff. So based off those kind of goals of how do you detect basic methods of persistence and things like that, we spent some time rolling our own sort of host IDS approach, which in the Etsy approach, given that we're a site that is kind of handmade, sort of things like that, what would we call our host IDS? We had to call it Trip Yarn because that's even funnier if you work at Etsy. Don't worry, it's not that funny here. Okay, so Trip Yarn's goal is to alert off real patterns of compromise and persistence. What are ways that people actually persist on systems and actually behave when they're compromising them? And what are some lessons learned that we've had out of that? So if you're looking for off-the-shelf persistence mechanisms, what you're doing is you first look at what are the legitimate OS-provided mechanisms to persist on that operating system. So whether that's startup items, whether that's launch agents, whether that's RC scripts, whatever the OS that you're instrumenting, what are the ways that legitimate persistence happens, and where do those exist? And then what you do is you treat any modification or additions to or changes or anything like that to those mechanisms as an event. Now, some events are going to be rare, some are going to be very common. Rare events are fantastic because you can alert directly off of those, right? A rare event, I threw a couple examples up there, but this list is a mile long, right? A new SSH key being added to a host, that's a really rare event. You can just alert off of that because the false positive cost is so low because it almost never happens. Same with cron tabs being created, things like that. Look at those host persistence mechanisms and see, okay, which of these almost never happen? Great, anytime they do is an alert. Which of these happen all the time? Well, that's where it gets a little more tricky. And what you need to do from that is not just get the data from an individual system. What you're really looking for is data from across your organization at this point. So I'm going to give a specific example here around kernel modules. So if our goal, let's take this as an arbitrary goal. We want to detect a malicious kernel module loading on an endpoint inside of the organization. So I think it's really important to talk about failures in talks too. We thought this would be a super trivial exercise. Our naive assumption was that kernel modules get loaded a ton at boot time and then very rarely at actual just runtime of the operating system when you're just using your OS. Kernel modules, our thought was that they almost never happen. Totally wrong. We're completely wrong on that. They happen all the time. It's insane. Go look at that sometime in terms of just the number of kernel modules going in and out of your kernel all the time. Okay, so we had to step back and say, all right, how are we going to approach this? Just doing some kind of whitelisting and blacklisting off of kernel names, it's not going to be effective in any way. Instead, stepping back and really thinking about the problem and thinking, what are you trying to really solve here? You want to know, did a malicious kernel extension load on an endpoint, but not just that it was on an endpoint, but it was interesting across the entire organization. So what you're looking for is this really unique? Is this anomalous inside the organization? And it can kind of boil down to a sentence like this. Did that module that just get loaded on that endpoint over there, has it been loaded on less than N systems across my enterprise in the last week or month or something? It's not so much that a kernel module got loaded, it's that, is that a new kernel module that has never existed on my network before, and did it just suddenly show up on some endpoint, and is that endpoint the CEO's laptop, right? That's the problem you're actually trying to solve. So stepping back a bit, also just from a high-level sort of techniques perspective, not to do with kernel modules or anything, but really around defensive tooling. As you're coming up with the custom tooling that's going to work for your environment, take a very good lesson learned from offense here, which is that as much as you can, you want to separate your tooling and your objectives. So this is kind of a bad example, but it gets the point across. Think Stuxnet. So for the operators of Stuxnet, they were not going to have reliable command and control, right? Because their actual objective was an air-gapped network that they had to kind of sidestep to get into. So if you don't have reliable command and control, you need to build all of your objectives into your tooling, right? Because you're not going to be able to say, your agent didn't just land on a box and now checks in and says, hey, what do you want me to do? There is none of that step. And so when your agent lands on a box, it needs to already know what to do and perform all of those objectives and then exfil the data some other way. This is the opposite of the way that you want to do effective attack tooling if you have reliable command and control. So if you have reliable command and control, you want a very minimal agent, because when your adversary, when the defender discovers that, when they find it, they start pulling it apart, you don't want them to know what you were actually after, right? You want them to just be able to pull apart a basic command and control agent that said, okay, I wait for commands and then I return the result of those commands back out. If you as a defender discover that, that sucks, because you know that this agent was compromised, or this host was compromised, but you don't know what they did in the past, you don't know what they're looking to do in the future, you don't know what their objectives actually were. Take this same approach from the defensive side. Your defenses are going to be discovered by an attacker, they're going to be reversed, they're going to be looked at, your attacker wants to know what you're looking for. And as much as you can, because you almost certainly have pretty reliable command and control over the endpoints in your organization, it's just that you're not used to thinking of it in that way. But we're essentially, right, botnetting your own internal systems, and you have reliable command and control there. So as much as you can, separate out the objectives, because when your attacker pulls down that defensive tooling, you don't want them to know entirely what you're up to. So you want to, as much as you can, pull that data up from the client side, send it up to the server side, and then when they discover that, they shouldn't be able to know every alert that's in place and everything that you're looking for. What they will be able to know is what data are you collecting, and based off of that, in a lot of cases, you can make inferences as to what people are going to be detecting and what they're going to be alerting on. In other cases, you just know that they're collecting a big set of data, and you don't actually know what are the real alerts out of that. And then also, just from an operational side, it's way easier. Your server-side stuff is going to be centralized. So a lot of this sort of stuff happens where you build a mechanism, you roll it out, and then you're not really sure what the thresholds are going to be for detection on that. And in practice, you need to adjust your thresholds for the first couple weeks that you're really rolling out tooling. Sometimes it's just an ongoing thing entirely. If you have to roll a new version of software out to all of your systems just to adjust a threshold, it's a huge pain. If you're just instrumenting them and collecting data from your endpoints and you want to adjust a threshold, great, now you do that on the server side and it's instant. So organizational level persistence, jumping back into persistence here. This is really, how do you persist across an entire organization and do it in a, hopefully in a really low-key sort of manner. So take almost every tech startup out there. They use Gmail and Google Apps. Take pretty much every enterprise in existence. They have some sort of VPN mechanism. As an attacker, for the most part, you want to reuse existing persistence mechanisms for an organization because they're way less likely to be detected, right? Think a command and control mechanism on an endpoint, and it's got to call out over the network. Network controls are getting better. Network detection stuff is getting better. You're more likely to get detected as an attacker if you're doing your own kind of, custom beaconing back to some endpoint that happens in a way that's totally unique, than if you just issue yourself some new VPN keys and go right in the front door. So these are the things as a defender that you want to really focus on instrumenting. And what we found to be effective here is really a mix between very automated anomaly analysis and just flat out manual analysis on this. And so what I mean by like manual analysis is generate rollups of the keys that have been generated today. For most organizations, that's actually not every day that keys even get created, right? A lot of times, most organizations start all new employees on a Monday or a Tuesday or whatever. And so you expect a lot of keys to be generated right before that, but you don't, let's say new employees start on Mondays, you don't expect a lot of keys to get created on a Wednesday, for example. So just manual rollups, and that can be as simple as, hey, do a rollup of here's all new keys created. It emails the security team and it emails the IT team, and it's just the job of the IT team to take a look at that and be like, oh yeah, that's all, that's, it's normal, that's all us, or like, wait, we definitely did not create that key today, and the guy that it said that created the key today is actually out on vacation, so like, what? That's the kind of manual analysis that you can never really automate, but the stuff that you can automate, the just automatic anomalies are, things as basic as unusual times and things like that. It's almost certain that your IT team did not create a key at 3 in the morning. Things like that. Unusual locations, that sort of basic anomaly analysis. So another case study example would be Gmail. Given a goal of trying to instrument Gmail to detect compromise of essentially domain admin accounts. Turns out Gmail provides a log of a lot of very interesting data via some not really commonly known APIs, the admin audit API and the email audit API. You can pull down logs for your organization from these APIs, and it's great. You pull down those logs so that you have a copy, and they're not just all up in Google. But then you also do alerting off of that, and you can alert off of very strong signals of compromise from that. Unusual sign-in, I mean, even from the most basic, like unusual sign-ins, to the ones that should almost never happen. Creation of new admin level accounts in an organization almost never happens. That should just generate an alert anytime it happens. A really good method of persistence, and I'll air quote persistence a little bit, from the offensive side is, hey, I don't even really want to deal with the pain of persisting on a host or on a network or anything like that. I just really want to read their CEO's email. Like, that's really what my end goal is after. Great, you don't have to do persistence for that. You don't need any sort of custom CNC for that. You just auto forward their email, right? And that's it. You don't even need to persist any other way. Just auto forward the CEO's email. They still receive their email, and you get a copy of it as well. So new mail filtering or new mail forwarding filters getting set up, that's pretty interesting to you as a defender. And then any changes to, I said two-factor auth settings, but really that's any changes to any security settings at all. If mandatory SSL got disabled, if two-factor auth got disabled, if anything like that got disabled, that's interesting. You want to know about that. That's almost always should have been a major policy decision and not just something getting turned off. So an example of, what this even looks like from the Google APIs, you can just build up alerts off of that. Like, hey, somebody got added to this new group. Here's who it was. Here's what group they got added to. Here's what it was done from. Great. It all was super benign. Good. We're done. OK, lateral movement. So any Street Fighter 2 fans? Anyone? Yeah? Awesome. OK, I'm going to do two high-level areas of lateral movement. This could be 8 talks in and of itself right here. But just network and systems discovery. So you land on an endpoint and you want to start operating in that environment. You need to discover what's in that environment. So that stage, and then kind of higher level information discovery inside your target. So the next couple slides I really think are the dumbest slides in this presentation, but they actually kind of work, which is hilarious to us. So around like network and systems discovery here, using endpoint firewalls as a detection mechanism, not as a blocking mechanism. So we've historically always done firewalls as a blocking mechanism. At this point, firewalls are almost even irrelevant because firewalls mattered when Windows listened on port 137 to the internet and we all had public IPs. It doesn't anymore. Using firewalls as an actual detection mechanism is interesting because think about shifting from deny firewall rules to allow an alert. So thinking about it from the offensive side, you land in a network, you want to start operating and start moving laterally across a network and getting access to the systems that are ultimately your objective. You have a bag of tricks and you have your favorite things that you look for in an environment. As a totally arbitrary example, it's like, hey, is there any MS SQL boxes in here? Awesome, because there's going to be one that still has XP command shell from the party back in the day. Let's go find that. Well, it turns out, if your organization doesn't use Microsoft SQL at all, and someone starts looking for anything being open on that port in your environment, that's really interesting because you know that there's nothing legit that should be using that. And so you overlap your detection for that. Obviously, you still do detection at the network level too, but it also has a lot of value on the client side. So if you set up client-side firewalls that say, hey, allow everything out. But if this endpoint ever starts trying to talk to these services that don't exist in my network but are interesting to attackers, you should also phone home as fast as you can and say something's weird. And one kind of almost side effect of this is this completely counters any sort of timing-based evasion or anything like that. It doesn't matter if you wait, you do a port scan over 3 weeks or something like that, you still have to connect to that port. And if you have to connect to that port, a firewall on the endpoint is going to see that. So no matter how slow you do this, it's still going to cause alerts. Okay, information discovery inside of the environment. Stepping back and thinking, what internal systems give attackers the information that they're actually after? It's going to be the same things that allow you to do your day-to-day job as just an enterprise. Wikis, source control, bug tracking, all of this sort of stuff that you use on a day-to-day basis. There's a reason you use it on a day-to-day basis. It's useful. It gets the job done. It has all the information. There's no better target for an attacker. Treat these things as very high-value pieces of infrastructure. These are interesting to attackers for exactly the same reason they're interesting to you. And you can start very cheap on this too. I mean, just in terms of effort, not even in terms of budget. Things around like the fact that your attackers are almost never going to be in your same time zone. So when someone's viewing, a bunch of tickets at 4 in the morning, great, that's either your remote engineer from that other time zone, or it's not someone from your environment. The other thing too is, and this kind of goes back to like with commands, bursts of activity. The way attackers use your environment is very different from the way that you use your environment. You don't go look at every ticket in a given group because you already know that. You go look at the most recent one that somebody filed for you yesterday and you're like, I hate that guy, I don't want to finish that ticket, but whatever. But you don't go look and read every ticket out there. So bursts of activity, things like that. Cool, all right, that's the end of the instrumentation section. Let's talk about how do we make attacks more expensive for attackers. And I'm going to run through about 5 different things on here. So how do we kill off some trusted routes? How do we remove a few specific cheap exploitation vectors? How do we do updates, but in kind of a more culturally sensitive way? How do we cut off a lot of just drive-by exposure? That's awesome. And then let's rethink the way that we've been doing security awareness training because it's not effective with its current goals. So how many people remember the DigiNotar stuff, right? The CA got hacked. They used that to then generate some fake certs for like Gmail and Facebook and all of your normal ones that you want to man in the middle. And then they owned up a bunch of people with that. So we were sitting around talking about that one day, and we're like, you know what would suck is not that. Like that's, at a certain level, that's an attack that is almost entirely out of your control, right? Until other mechanisms do CA pinning and things like that, it's almost entirely out of your control. But what would really suck is if some CA that no one has ever used got popped and then got used to sign a Gmail cert or some other high-profile cert. And if we got owned up because of that. So we started thinking about that. I'm like, okay, what could we actually do about that? And the trick is here to really just drop your attack surface as much as you can on this particular topic here. So if you can kill off certs that aren't even used in your organization, when one of those gets owned, they can't silently man in the middle all of your traffic now. You can do kind of a first order approximation of just looking through the number of certs that are in your standard enterprise or your standard endpoint build and being like, oh, there's no reason we'd ever need that one, there's no reason we'd ever need that one. But that's a totally arbitrary decision, and you're ultimately going to get something wrong there. You need to make this decision based off real data. And so what we did is we built a system to anonymize and analyze several months worth of traffic from our main office to the internet. So just our employees' internet traffic, anonymize it, and it's a super simple system. All it did was say, all right, if this is SSL traffic, record what CA is involved in this. What is the CA that's signing those requests for, or what is the CA that is signing those certs for the traffic that we're seeing? Cool. We found that after 3 months of recording the data and then analyzing it, less than 29% of the certs that were on our standard builds were actually used at all. And almost all of those, here's actually some of the raw results. I had to chop this off a bunch because it drops off super quick. So like, here's the ones that if you rip those out, it would completely affect the enterprise. And then it just goes off in this total long tail of 0.01 CAs that got seen 5 times maybe. And so we published the full list and everything up on that blog post if you want to check it out later. So the interesting thing though, and the core thing to realize from this is if you want to go ahead and remove those certificates, you want to do it based off of data and not just data at one point in time, but an ongoing set of data. Because if you just remove those certs and somebody starts using a different cert, then great, you've shot yourself in the foot because you're teaching them to click through certificate errors, right? That would suck. So what you do is you keep this analysis going, and when a new CA starts showing up in that system, like, okay, that was a legit one. These are all of our endpoints. We have control over them. Add that CA back to them. It's not a final decision that like, okay, these are the only CAs that will ever be blessed from now until the end of time. This is an ongoing sort of thing. Continue that analysis, add and remove as appropriate. And likewise, if you see one CA that showed up 5 times once and then you never see it again, consider removing that. Okay, Java. Java is cheap, reliable, and efficient. Unfortunately, that's for attackers. Not so much for you. Okay, awesome. How do we get rid of it? So we killed Java web plugins from our entire enterprise. And it was an interesting learning experience for us. What we learned was, first, once we set that as a goal, we're like, all right, we want to kill Java web plugins. Again, not Java, the programming language, Java web plugins in your browser. What did we learn when we do that? First, we need to figure out, okay, who even uses this stuff? Like, given that we want to get rid of Java, who are we going to break? Who are we going to affect? And so we had to do a lot of analysis around that of who even uses Java in our enterprise. And what we found is almost no one. We probably got really lucky there, but almost no one needed Java in the browser. And what they did, they needed it for very specific reasons. It wasn't, hey, I need Java to browse the internet. It's, hey, it was our network operations group, and there was some old like network management hardware that it used Java applets for management. And so they needed to do that. But they interface with that equipment at most, let's say once a week, probably a couple times a month. And so you can start to address the problem from that side. Given that's not a day-to-day thing, great. How can we remove Java from all of our endpoints, but still give them that functionality? And so what we did is we channeled the 1990s again, and we built jump boxes. And so the cool thing for that is when ops needs to go use Java for one of those things, they can VNC or NX to a jump box that has Java installed. Those boxes can only hit the networking equipment that they need to hit. They can use that, and then they're done. In the same way that it's often seen as like lack of patching is like laziness on a defender's part, right? Which is a whole fallacy to begin with. But laziness is often seen as the problem. In this case, you make laziness the solution, right? Because if I'm a network operations guy and I need to go log into that other system to then log into another one, I'm only going to use that other system for that task, and then I'm going to be done. And I'm not going to go browsing the internet on that one because it's a pain. So you make laziness actually your solution there. And then you can do lots of restrictions on those boxes too, which is really nice. You can say those boxes can't even hit the public internet. They're just jump boxes that just do this stuff, so you can re-image them all the time if you want. And it's only a few boxes to patch when you need to update Java. So an interesting thing about how many people have OS X in their environment? Curious. Cool. Okay. So funny story about Apple and Java. And they may have changed this now. This was certainly true a couple months ago when we did this. But when you apply security patches for Java, it re-enables Java. It doesn't do a check first and say like, hey, Java's disabled, so I'll patch it and leave it disabled. No, it helpfully re-enables Java, which like broke the problems that we were trying to solve in the first place. So in an Apple environment, you actually need to continuously kill Java with fire. It needs to just always die in your environment. So like this was a graph of Java showing back up in our environment. We had no idea the first time that this happened, right? We were like, oh, awesome. We've made the policy decision to kill Java. We built these jump boxes. Awesome. We turned off Java on all of our endpoints. And then the first Apple security patches showed up, and suddenly Java was back on all of our endpoints. And we're like, what just happened there? So you need to kill it on an ongoing basis. And you'll see spikes on the graph that are like, oh, Apple shipped new security patches today. There goes Java in our enterprise, and there goes Java in our enterprise again. Okay, browser updates. Absolutely one of a great vector for attackers, right? Out-of-date browsers. How do you force browser updates? But how do you do it in a cultural way where you're not being a pain to people, where you're not like forcing reboots and forcing activity like that make people hate the security team? So we wanted to do this in how could we get that end goal of up-to-date browsers, but not have people hate the security team at the end of the day, because it turns out we like having beers with everyone else in the organization. And then they stop having beers with you if you make them reboot their computer all the time. So what we did is, at our internal SSO point, So it doesn't even have to be SSO in your environment, but there's almost always going to be in every environment some sort of intranet site, some sort of internal point that almost everyone in the company hits on a daily basis, just to get their job done. In our case, that was the SSO point, but it can be anything in any environment. And what we did is we built in browser detection logic to that point. And so, oh man, I'm going way over. It's like 20 minutes. Okay, so we built in detection logic there, and we said, okay, if you have out-of-date browsers, let's force our updates there. But the trick is, and this is the painful lesson we had to learn, is that UX is totally key. User experience, right? Show how quick it is to update. So this is kind of a mock-up of what we do. Trick is always show a sad kitten. There you go. You get everything done if you show a sad kitten. You are making the kitten sad by having an out-of-date browser. In this case, you'll notice your copy of Mosaic is not Netscape Navigator version 1. So apparently this is 1987, and you need to update your browser. The other key actually is this button right here. And it's just the concept of that button. That button is the button that says, nope, I'm bypassing this. And that's the button for like, hey, I'm in a meeting with the CEO or something. I don't have time to update my browser. I promise I'll do it later today, but I don't have time to do it right now. And the trick is all about the messaging on that, because you say, okay, treat this like you do a fire alarm, right? It's there for a reason, and it's gonna generate noise when you do it. So in this case, you push that, you push that button, that's going to generate an alert to the security team, and we're going to have to deal with it. So, hey, use it wisely. It's there for you when you need it. Otherwise, update your browser. It's 2 clicks. And what we could not believe out of it, we thought we would do this, and everyone would be like, yeah, don't care, hit the button, hit the button, hit the button. It actually works. It's amazing. So we started graphing all this stuff. And there's a browser update happening. There's everyone being out of date, updating, and you watch a couple days later, almost the entire organization is patched. And then you have people coming back from vacation and other spots and hitting it again. We couldn't believe that graph when we first saw it. Users will install malware because an ad pop-up told them to. This is hilarious and sad, and the reason your security team drinks. Right? If a pop-up says, hey, you don't have a firewall, click here to get a firewall because you like security. People, not making fun of people, like people will do that, like even for the best of intentions, right? They'll be like, hey, I want to keep secure here. Like, I don't want to get my organization compromised because of me. I've got a thing on my screen that tells me I'm not secure and I need to install a firewall. I'm going to go install a firewall. Or shout out to, if anyone remembers Bonsai Buddy from back in the 90s. There's Bonsai Buddy. The interesting thing from the defensive side here is this is awesome. You can kill this, and you can kill this for free. It's probably one of the best defensive mitigations that will ever exist, because you can push ad blocking plugins to your entire organization and just kill this entire vector of compromise for free. It's awesome. If you never get this pop-up that says you're insecure and install a firewall, they're not going to install that piece of malware that says it's a firewall. Security awareness training. Oh yeah, sorry, I should have left up the pool shark. Totally awesome. Okay, so historically, how many people have either attended or done like security awareness training and like, here's a phishing attack, don't fall for phishing attacks, right? That's always been our goal, has been, hey, don't fall for phishing attacks. And it's great from one side because you can graph it and you can say, hey, the first time we did it, 80% of people fell for it, and then this graph goes down because we did it again, and now it's 75%, and now it's 60%, and it's lower and lower, and you feel really good. The problem is this is totally the wrong goal, because the point of that is to get that graph to 0, right? The implicit goal of security awareness training is that no one will ever fall for it. That's an impossible goal. That will never happen. That graph will never go to 0. It'll hit 20 or 30% and then stay flat. Another way of thinking about that is if you go from being a lot on fire to slightly less on fire, you're still on fire and it still sucks, right? So what you actually want to be focusing on is not reducing the number of people that fall for phishing. That's great, like why not? That's a side benefit, but it's not your real goal. Your real goal is actually increasing the number of people who report it. So if you see something, say something, right? If you can train your organization that when they see a phishing attack, even if they fell for it, even if they clicked on it, even if it's a day later, come talk to security and let them know. That's the metric that you actually want to track, and you want to increase the number of people who report it, because as an attacker, I only need a couple people to fall for my phishing campaign, right? But if somebody in that group who fell for it then reports it to security, you've won as a defender. You can go start doing IR. You can start doing recovery from that. OK, final section of the talk, running attack simulations. So problems with pen testing. How many people in here are pen testers? OK, it's an awesome job, but there's also a whole lot of problems with it. And that's, all right, I'm going to be in trouble. So problems with pen testing are really well understood in offense, but they're not really well understood in defense. Am I at -10 already? OK, you can start throwing things at me, too. It's fine. So the problem with pen testing is it gives you a big context-free list of things that you should go patch or things you should go do. The problem, what it doesn't give you is how real attackers actually operate against your environment. And that's a different area that you want to be focusing on. You want to be running attack simulations that show how attackers actually achieve goals against your organization, and absolutely not to prove that compromise is possible, because it is. Just full stop. Compromise is possible. What you want to use this data for as a defender is figure out where you want to build your detection mechanisms, how to focus on that, where you should be focusing your efforts, where you should be building better detection mechanisms. From an organizational side, these complement vulnerability enumeration and compliance and that sort of stuff. These things are checklists, though, right? Vulnerability enumeration you do to get a big checklist of where your patch management is failing and all that sort of stuff. Compliance you do because you have to do it. It's compliance. But the problem is checklists aren't owning you, right? Attackers are. So the four things that what we've kind of distilled down to what we found effective out of running attack sims are: make it goal-oriented, talk with your attack teams. Hacktivity is a unique conference, I will say. All right. Right, yeah, thank you. Yeah. The talk actually is this long. I'm not stalling. OK. Make it goal-oriented. Make it read the CEO's email, something like that. Some goal that you know your attacker's actually after. This is the biggest one. This is real tough to do as a defender, but it's incredibly important. Your full organization is in scope. There's nothing more hilarious to attackers than the concept of scope, right? That is something attackers do not have, and yet defenders constantly constrain their pen test teams and things like that. With scope, it's utterly hilarious to an attacker. Simulate the real patterns of compromise, how they actually happen. If you want to simulate a popped endpoint, start them on a standard build of one of your laptops. You want to simulate SQL injection, start them on a database. You want to simulate remote code execution on a front-end web server, start them on a front-end web server. And break it down into iterations. Don't just run the goal. Oh, man, even the clock is blinking at me now. Don't just do it as one 2-week thing. Still do a 2-week engagement, but break it down into multiple iterations inside that. What you're looking for are attack chains. This is where I'm just going to start flying now. Break it down into attack chains. Show how attackers went from A to B to C, and why they went. And just as importantly, what they didn't do. So for example, you may expect them to go search your wiki for network diagrams, but it turns out you left zone transfers on, so they didn't even need to do that, because they just map out the entire internal network that way. You want to simulate realistic behaviors and patterns. And what you want to do is also vary your different attack profiles, because some attackers are going to be just smash and grab. They don't care how noisy they are. They just want to grab your objective and then get out of there. And other ones, their whole objective is just to maintain persistence for when they want to use your environment 6 months down the line. These attackers operate totally differently, and you want to simulate all of them, because you want to see what behaviors overlap and build your detection mechanisms there. Holy crap, we made it to conclusions. Defend like an attacker. This is totally the theme of the talk. Think about defense from an offensive mindset. Increase your attacker cost. Build detection mechanisms around real attack patterns. And then have the capability inside your team to develop custom tooling. And you're awesome. Thank you.